Hi, I'm Jeff Twardokas, a first-year PhD student in the Wireless and IoT Security and Privacy Lab at Rochester Institute of Technology. Today I want to talk to you about one of the projects we've been working on with connected vehicle security. One of the outcomes of this project has been our preliminary work being accepted at the InfoComm 2022 conference in a paper authored by myself and my advisor, Dr. Hanif Rabari.
In this project, we work with the 5G Cellular Vehicle-to-Everything, or C-V2X protocol. 5G C-V2X is quickly becoming the dominant technology for vehicle-to-vehicle, or V2V, communication around the world. In 2020, the connected car market being built around V2V communication hit a staggering $56 billion value, with growing deployments in the United States, China, and parts of Europe being driven by major buy-in from governments, industry partners, and automakers. A major benefit of V2V is its expected ability to significantly increase roadway safety by preventing almost 600,000 vehicle crashes every year, saving the U.S. economy almost $71 billion annually. V2V is also considered an enabling technology that will help make fully autonomous vehicles a reality in the near future. To prevent vehicle crashes, connected vehicles use V2V protocols to transmit periodic basic safety messages, or BSMs, that allow the receiving vehicles to react as needed to avoid a potential collision. This project began with the observation that C-V2X is now over 5 years old, but its security has remained largely untested. This is a serious problem because denial of service or DOS attacks in V2V can lead to crashes, injuries, or even death. In this project, we have exposed new physical and MAC layer vulnerabilities in 5G C-V2X, devised 2 stealthy and difficult to mitigate denial of service attacks that exploit those vulnerabilities, and experimentally validated the catastrophic impacts of these attacks. In our first attack, targeted sidelink jamming, the attacker goes after a single victim vehicle with the goal of blocking her BSMs so that other vehicles are not aware of her presence. The attacker does this by identifying one BSM from her target, anticipating and jamming the next several BSMs that follow. In our second attack, sidelink resource exhaustion, the attacker goes after the entire C-V2X system, this time with the goal of reducing the C-V2X data rate and consequently the safety of all users on the road. The idea for this attack is to exploit a MAC layer vulnerability to manipulate vehicles' behaviors by making atypical transmissions. In a hardware testbed using software-defined radios to attack state-of-the-art commercial C-V2X devices, we've shown that our targeted sidelink jamming attack is very effective, reducing the victim's packet delivery ratio to less than 10% in just 10 seconds, while at the same time having minimal collateral effect on other vehicles, thus ensuring the attack is stealthy. Through MATLAB simulations of a C-V2X environment, we show that our sidelink resource exhaustion attack is also very effective. In fact, it can reduce system-wide packet delivery ratio by as much as 50% when the channel is at its busiest. We also show that packet delivery ratio for all vehicles is inversely proportional to channel busyness, meaning that our attack is the most effective when the most vehicles will be impacted by its effects. We evaluated our attacks using software-defined radios in a hardware implementation we designed as a C-V2X prototype. For example, in the sidelink resource exhaustion attack, this mobile cart with one laptop and one USRP B210 represent multiple vehicles and the attacker, while the victim is a real vehicle with a roof-mounted USRP B210. The attack is launched by running a customized attack program written as an extension of the open-source SRS-RAN C-V2X software. In this demonstration, the USRP B210s are synchronized to GPS by live satellite signal. From the victim's perspective, while the attack is ongoing, the channel resource utilization steadily declines as a result of the attack. This means that more packets are colliding and being lost, reducing safety in the C-V2X system. Thanks for watching this presentation. If you want to learn more about our research, please visit our website. Also, check out our InfoComm paper by scanning the QR code on the right side of the screen. Thanks again.